So, you want to understand artificial intelligence. You could dive into neural networks, algorithms, massive data sets, or we could try something different. Today, we're going to crack the code of AI, not with technology, but with a simple ancient puzzle. It turns out the answer has been hiding in plain sight for centuries.
So yeah, we're not starting with computers or code. We're starting with a shape you've known your entire life, a square. Why? Because sometimes the biggest, most profound ideas are hiding in the simplest things.
Okay, so here it is. A perfect square. It feels solid, whole, like a single, complete thing.
There's a sense of finality to it, isn't there? Like, that's it. It's a square. Nothing more to see here. It just is. But that, right there, is where the magic is about to happen. And just like that, it's gone. That solid single form is broken apart into this collection of smaller shapes. Now, the original square has vanished, that's true. But, and this is the important part, all the stuff that made it up, all that area, is still right there, just waiting for us to do something with it. So, with those exact same pieces, we can make a bird, or shuffle them around again, and now we have a house. Look closely. We didn't add a single new piece. We didn't take anything away. The only thing that changed was the structure, the arrangement. That idea is going to be absolutely crucial, so hang on to it. All right, a fun little puzzle. But what on earth does this ancient game, it's called a Tangram by the way, have to do with cutting-edge AI? Well, as it turns out, pretty much everything. The connection is way more direct than you might think. I know, on the surface they seem worlds apart. One's a physical toy you can hold in your hand, the other is this incredibly complex digital thing. But when you look at their core, their fundamental principle, they're running on the exact same operating system, taking existing pieces and finding new, meaningful ways to put them together. The key process that links these two worlds is something called dissection. Now, it's a fancy-sounding word, but the idea is dead simple. It just means breaking something whole down into its basic, fundamental building blocks. And this is where the analogy gets incredibly clear. In the Tangram, a square gets broken down into little geometric shapes. In AI, a huge amount of information, we're talking text, images, sound, you name it, gets broken down into its own fundamental units. We just call them tokens. So, for example, an AI doesn't see the sentence AI learns from data the way we do, as a complete thought. No, it sees the pieces. It sees the tokens. AI learns from data. By themselves, they don't mean much, but put them together in the right order, and that's where intelligence starts to spark. So this whole process of breaking things down and building them back up isn't random. It's governed by a set of rules, a kind of playbook. So let's take a look at the 3 core principles that really explain how AI thinks. Okay, principle number 1, and this one is a real game changer for how you think about this stuff. Intelligence isn't necessarily about creating something brand new out of thin air. It's the profound act of skillfully rearranging what you already have. Just think about it for a second. A Tangram uses the same handful of pieces to create hundreds of different shapes. An AI does the exact same thing, but with words, with concepts. Take AI predicts market probability. Now flip it around. Market probability predicts AI. See that? Same exact pieces, same tokens, but a completely different meaning. The intelligence isn't in the words themselves, it's in the arrangement. All right, our second principle feels almost like a law of physics. It's this idea that within these systems, nothing is ever truly created or destroyed. It just gets reconfigured. There's a scientific term for this. It's called invariance. All it means is that there's some property that stays constant, that remains unchanged, even when everything else around it is being shuffled and transformed. So, for our Tangram puzzle, the invariant property is super simple. No matter how you arrange those little pieces into a bird or a house, the total area never, ever changes. It's a constant. So what about for an AI? Well, for an AI, the invariant property is the pattern it learned from all its data. The model isn't just inventing new facts out of the blue, it's finding new ways to express the deep statistical relationships it has already mastered. That knowledge is conserved. And that leads us right to our third principle, which tackles a question I bet a lot of you have been thinking about. Is AI really creative? Well, according to our puzzle analogy, the answer is a definite yes, but it's a very specific kind of creativity. It's the power of recombination. I mean, we see it all the time now. An AI can write a story, it can generate computer code, it can whip up some amazing analysis. But it's doing all of that by recombining the huge library of patterns it's already learned. It's what we call combinatorial creativity. Just like with the Tangram, you're not getting any extra pieces magically added from the outside. The staggering potential, all that creativity, it comes from the nearly infinite number of ways the existing pieces can be combined.
So, okay, we've gone through the mechanics, we've looked at the principles. But what's the deepest truth here? What does this simple little puzzle really tell us about AI? It's all about shifting our perspective on what lasts and what's just fleeting.
In the Tangram, any single form you make, the bird, the house, whatever, it's temporary. You can always break it apart and make something new. The exact same thing is true for AI. Any specific answer it gives you, any image, any line of code, it's just one possible output. It's temporary. So what is permanent? What's the thing that lasts? For the Tangram, it's those 7 unchanging pieces and the rules of how they fit together. For an AI, it's the learned pattern, that deep, complex web of relationships it figured out from all the data. The outputs come and go, but the underlying knowledge, the structure, that endures.
And that brings us right to the core of it, the fundamental truth that ties this ancient puzzle and modern AI together. It's not about the pieces themselves. It's all about how they're arranged. As you see here, intelligence emerges when pieces are arranged in meaningful ways. That's the whole game. So, as we keep getting better and better at breaking down the world's information into smaller and smaller pieces, and as we learn more and more complex ways to put them back together, it leaves us with this one final, really exciting question. If all this intelligence is just a grand act of rearrangement, what incredible, unimaginable new shapes have we not even discovered yet?